In this video we're going to talk about completing the square method. You know that you can solve quadratic equations or expressions using the formula method or the completing the square method. So in this session we're going to solve these quadratic expressions using the completing the square method, and we're going to graph them. Okay, so you know that the general form of a quadratic expression is f of x. Let's say f of x is equals to ax squared plus bx plus c. Okay, in this a is your coefficient of your x squared, b is your coefficient of x, and c is just a constant. Your f of x in this case just represent your y, like that. Okay, now what formula do you want to use when you are coming up with or how do you solve these completing the square method? Okay, so let's start. Let's use the same general formula. We're saying ax squared plus bx plus c. Okay, this should give us 0. Okay, so now what are we going to do? We want our function or our expression to be in the form of a, where we factor out a x plus p, okay, squared plus q, like that. So we want to achieve this expression. Okay, so that's what we want. Your p in this case represents the turning point at the x coordinate. Okay, the turning point at the x coordinate. Okay, then your q at this point, this just represents your vertical shift, in the y coordinate. Okay, so you should know that as we start solving. Okay, so let's start. So let's factor out a. So when we factor out a, what are we going to have? We have a, your x squared will remain, plus b over a x plus c over a. Okay, this way expression is equals to 0. Okay, now what are we now going to do? You realize that if we multiply a with everything in the bracket, it takes us back to the original expression. That's what you want to achieve each step that you take. Okay, so let's now do that. That factored out a. What we are going to do now, we are going to have the coefficient of x and square it. In this case, b over 2, or b over a. So b over a multiplied by half. We're going to find the half of this. This will just give you b over 2a. Okay, so we're going to do that. So now what are we going to have? So you realize that we have our a outside. Your x squared is there, plus. Okay, now you can write this. Okay, b over a x, plus this expression, but now you square it, right? Okay, so let's just write that. So you have b over 2a. We said you square it. Okay, you're going to do minus again the same expression, b over 2a. This should be also squared again, plus c over a, like that. Okay, so let me put this is a big bracket. Let me also indicate this one is a big bracket. Okay, we've done this twice because you wanted to take it back to take you back to your original expression, like we earlier said. Okay, so now let's continue. Now what we are going to do, we are going to ignore this part. We are going to ignore this part because it's the one that we've halved. Okay, So we're going to ignore this part. So what are we going to have when we ignore that part? So you have okay, you have the big bracket. Now we're going to put the ones with squares in their own bracket. Okay, so we have x squared. Now we have x, this x, and this expression. So x plus b over 2a. We're going to put these ones in a square because they are squared. Okay, minus b. When we like we squared here, your 2 will go will be on b, so it will be b squared over 2 squared, that is 4, a squared, that is just a squared. So that would be 4a plus c over a. Okay, now this is what we have as for now. Okay, allow me just wrap the top part. Okay, now what do we have? So you realize that this expression that is here, this should be your q in this case. Okay, then this should be close to this expression. That's what we want to achieve. Okay, so what we are going to do, we are going to simplify this one. Then after we simplify this one, we distribute the a. Okay, so let's just do that. Okay, so let me get this expression. So if I'm simplifying this expression, what am I going to get? I've got negative b squared over 4a plus c over a. If I get 4a as the common denominator, 4a squared actually, this is squared. Okay, 4a squared. So 4a squared divided into this will just give us negative b squared plus 4a ac. So this is the expression that we have. Okay, then so now what are we going to have? We are going to have our a in this case. Okay, and we have our x plus b over 2a. Okay, let's put this, then let's put this as a big bracket. This is squared. You have your minus, now you have your b squared plus 4ac over 4a squared, like that. Okay, this is in a big bracket like that. Okay, so now what are we now going to do? We said we are supposed to distribute the a, so let's distribute the a and we see what we are going to have. Okay, so when we distribute the a, what you have is because we want to achieve this expression. So what are we now going to have? So you realize that when you distribute the a, you have x. This will be, okay, let's say this, when a multiplies with that, so you have a x plus b over 2a. Okay, minus, now there's a squared here, so it will cancel with one of the a's. Okay, so you just remain with one a down there. Okay, so what are we going to have this side? You have minus b squared plus 4ac over 4a. Okay, so now when you want to find the turning point, okay, when you want to find the turning point of this expression, your turning point in this case will be this, which is your q, right, which is your p, right? So to be negative p comma q, that will be your turning point. So your negative p in this case is this expression. Okay, that's your negative p. Then your q in this case is this expression. Okay, that is your Q. So that's how you find the turning point. Then when you want to find the line of symmetry, where a line that cuts the same graph, or the graph that you're going to draw, into two equal parts, you are going to get this expression that is in the bracket and you equate it to 0. What I'm saying is x plus b over 2a. You know, this you equate it to 0. Then what you're going to get will be a value of x which cuts the graph into two equal parts. Okay, so now let's solve an example. Let's say you're given f of x is equals to x squared minus 4a. Okay, so like we did initially, you factor out a. Our a in this case is the coefficient of x squared. Our coefficient of x squared in this case is just a 1. Okay, let's just put it for the sake, okay, like that. So when we factor out the a, we have x squared minus 4x, like that. Okay, this is x. Okay, now what are we going to do? We said you get the coefficient of x and you find its half. So negative 4 multiplied by half, this will just give us a negative 2. Okay, so what do we do to this one? We square it, and we do like that. So what are we going to have? We are going to have our 1 over x squared minus 4x. Now we bring our negative 2. Okay, we said, okay, this is a plus, so this one you square it, that's what we said, and you have to minus it again, you square it like that. Okay, okay, so this is the expression that we are going to have. So let's continue now. Let's solve what is in the brackets. So what did we say? You ignore this one, and those ones with the squares, you put them together. Okay, so what are we going to have? We have x minus 2, and you square these ones. Okay, then your negative 2 squared, that is just a 4, right? So you have a minus, this minus, and a 4 here. Okay, so let's just do that. So what are we going to have? You have a 4 here. So this is your expression. Then when you distribute your 1, so it will just be like, let me just say the same expression, x minus 2 squared minus 4, like that. Okay, then what did you say our turning point? So our turning point in this case, we said our turning point just equals to your negative p comma q. In this case, your turning point now will be what? Here is negative, so your value of your x, or your x coordinate on the turning point will just be a 2, right? Okay, then for the q1, you just get this one, the constant, right, like we said. So this is just a negative 4. So this is our turning point. Okay, so now that we found our turning point, let's also find the line of symmetry. What did we say the line of symmetry is? You get this expression that is in the brackets and you equate it to 0. Okay, let's just do that. So x minus 2 is equals to 0. So x in this case will just be at 2. So at position at 2, that's where the graph is being cut into two equal parts. Okay, now let's also find the y and the x intercepts, where the graph cuts the x-axis, where the graph cuts the y-axis. Okay, okay, so what are we going to have? We're saying for us to find the y, let's start with the y-intercept. So to find the y-intercept, where the graph cuts the y-axis, so we're going to set x to be equals to 0. Okay, so our equation was f of x is equals to x squared minus 4x. Okay, so now what are we going to have like that? So when we set this expression, so say f of 0 in this case will be wherever the x will be pressing 0, so the 0 squared minus 4 x, which is 0. Okay, so what are we going to have? 0 squared, that's 0, so you have negative 4. Okay, no, okay, negative 4 multiplied by 0, that is just a 0. Okay, so our intercept therefore will be what? 0 comma 0, right? This is our y intercept. Let's find our x intercept. Okay, our x intercept. So where the graph cuts the x axis. So what are we going to now do? So again, you're going in this expression now, you're going just to set your y to be equals to 0. So let's just do that. So in this case, we're going to set our function f of x to be equals to 0. So to be 0, or let me just write it the other way. Let me say x squared minus 4x is equals to 0. Okay, so now when we solve, what are we going to have? Let's factorize our x. So to be x, here remain with x minus 4 is equals to 0. So what this expression just tells us is that x is equals to 0, or the ones that in the bracket x minus 4 is equals to 0. Okay, so now we've got two points where this graph cuts the x-axis. We've got at the point x is equals to 0, and at the point x is equals to, when you take negative 4 on the other side, just becomes 4. So this is where this graph cuts this graph cuts the x-axis. Okay, so now let's just do that. Now let's draw the diagram. Okay, which one are we going to rub? Okay, let's just rub this part. We've already found our x and our y. Okay, so let's draw. What are we going to have? So let's say okay, not really like drawn to scale though. Let's say this is our, let's say this is our x, our y axis. Let's say this is our x axis. Okay, so now what are we going to have? We've got points like we said the turning point. Let me just say let's say if this is negative 4, and let's put our 2 here. Okay, we said this is our turning point. Okay, which is that. Then we said this graph cuts the y axis at this point. We said 0 comma 0, which is the y intercept, which is just this point. Okay, then we said we've got two values of x. We've got x is equals to 0, x is equals to 0, or where x is 0 is just, it will be just that point as well. This is 0 comma 0. Okay, then another point that we said is 4, which is there. So our 4, let's put our 4 here, and that is our 4. So now how are we now going to draw our graph? Now let me give you a clue. If you have like in our scenario, if you have like we had x squared minus 4x. Okay, when your a is greater than 0, it means your graph will have a minimum like that. It will have a minimum turning point. Okay, because you know that the coefficient of x just here is 1. Okay, so even in our case, because our a in this case is greater than 0, 1 is greater than 0, so the graph will have a minimum point like that. Okay, so now let's draw our graph, and the opposite is true. If you've got a when a is less than 0, your graph will have a maximum point. Okay, to have a maximum turning point like that. Okay, so let's just do that. Now let's solve our graph. Okay, so let's join our points. So this graph will start from there and it will pass through the turning point and it will go like that. Okay, so this is a graph of f of x is equals to x squared minus 4 a, like that. Okay, so our turning point in this case we said is 2 comma negative 4. Okay, and this is the x and the y intercept. This is also the part of the x intercept. So this is how we solve you know your graphs when you're given graphs in terms of completing the square method. Okay, let's also try to solve another question. Let's say you're given you're taught to use completing the square method to find the turning point of x and y intercept, and also you have to sketch the graph, and you also have to find the line of symmetry. Okay, so let's say you are given maybe let's just say you're given a scenario where you have let's say f of x is equals to 3x squared plus 6x minus 4. Okay, so what are you going to do? Like we did in our earlier case, you factor out 3. So when you factor out 3, it will be 3x squared plus 6 over 3 x minus 4 over 3. Okay, because you're always trying to go back to your original equation. So like we did earlier, so when you do your 6 over 3, this will just give us a 2, right? 6 over 3 will just give us a 2. Okay, so we can replace that with a 2. Okay, now what are we now going to have? This, we are going to get the coefficient of x and we're going to find its half. So 2 multiplied by half, you know, 2 and 2 just divide, you just have 1. Okay, then you square this one. So what are we going to have? You have a 3 x squared plus your 2x. Okay, then what did we say? It's half, which is 1. You square it and you also do minus 1 squared like that, minus 4 over 3. That's what will take you back to your original expression. Then you ignore this one and you get the ones with the squares, you put them together in the same bracket. Okay, let's just do that. So you have 3 your x plus 1. We're saying these ones should be squared. We've ignored the 2, so you have minus 1 squared. In this case is just 1, right? Minus 4 over 3. Okay, so now what do we have? Okay, we have that. So now when we solve this part, negative 1 minus 4 over 3, what are we going to have? We have got 3, 3. When you have 3, what are you going to have? So this is 3 multiplied, that is negative 3. Then 3 multiplied by that is just negative. Okay, so just have negative 7 over 3 like that. Okay, so that's what we're going to have there. So let's just replace that. Okay, we're saying here we have negative 7 over 3. Okay, now that we have that, what do we do? Let's now distribute the 3. So when you distribute the 3, this 3 multiplied by this, and the 3 multiplied by that part. Okay, so let's just do that. So you have 3 x plus which is 1, then there's a square here. When you the 3 and the 3 will cancel, right? So in this case, on this other side, you just have a negative 7. Okay, now this is what we have. Your turning point in this case, your turning point, and like we said, this, a negative p comma q, negative p comma q. Our negative p in this case, we have, we've got 1 here, and it's positive, so it will be a negative 1. Okay, you just alternate the signs. Then your q is a constant, which is negative 7, so it will be negative 7. So this is our turning point. Then to find the line of symmetry where it casts a graph into 2 equal parts, so just say x plus 1 is equals to 0. So x in this case is at negative 1. So the graph, this graph will be cut at a negative 1. Okay, so we've known our line of symmetry is that. Okay, so now what other thing can we find? Let's find the y-intercept. Our y-intercept, okay, wherever there is x, we press 0, so it will be f. Okay, it will just be f. So our y-intercept in this case, it will just be, we're saying it will be f. Wherever there's x, we'll be pressing 0. So f of 0 is equals to 3, 0 squared plus 6, 0 minus 4. 3 multiplied by 0, that is just 0. 6 multiplied by 0, that is just 0. So in the end, you just have a negative 4. Okay, so in this case, our intercept will just be 0 comma negative 4. Okay, now let's find the x-intercept. Okay, allow me to wrap this part. Okay, okay, so our x-intercept, we're going to get the whole equation and equate it to 0. Okay, so what are we going to do? Okay, so we are having 3x squared plus 6x minus 4. This is equals to 0. Okay, now for us to solve this one, we're going to use the formula method. Okay, and you remember a formula for a quadratic expression, just x, because we're trying to find those 2 points. So negative b, positive or minus the square root over b squared minus 4ac over 2a. Okay, so let's just do that. So we'll have x is equals to, in this case, our b is just 6, so it's negative 6, positive or minus the square root over b squared, that's just 6 squared minus 4. Our a in this case is just 3. Then our 4 is just our c is just negative 4 over everything over 2. Our a is 3. Okay, so let's solve. So we've got negative 6, positive or minus. Now 6 squared, so I have the square root of 6 squared, that is just 36. Negative 4 multiplied by negative 4 multiplied by 3 multiplied by negative 4. you get plus 48. You're going to get positive 48. Everything over 2 multiplied by 3, that is just 6. Okay, now what are we going to have? Let me just use the other part. So we have negative 6, positive or minus the square root of 36 plus 48, that is just 84. Everything over 6. Okay, now here the square root of 84, in case you're not, in case you're not allowed to use a calculator, in case they allow you to use a calculator, you can do that. You punch it. But in an event where they they don't request you to use a calculator, what are you going to do? Just write it there and then, and just represent the same expression on the graph like that. But on my end, I'll use a calculator. So what am I going to have? I'm going to have negative 6, positive or minus the square root of 84, 9.17 over 6. Okay, so what am I going to have? The first value of x that I'll have when I do negative 6, so I have let me say negative 6 plus 9 over 17, 9.17 over 6, or negative 6 minus 9.17 over 6. Okay, so my x values that I'll get when I punch that, the first one I'm getting 0.53. The other one, okay, these are just approximations. Okay, I've rounded off. This one I'm getting negative 2.3, negative 2.53. Okay, these are the points that we have. So now how do we graph this function? So let's just graph this one. Okay, okay, so let's draw a graph. Let's say this is our graph. Okay, okay, so we said our turning point in this case, we said it was negative 1,7. Let me just approximate. Allow me to say this is negative 1 and this is negative 7. Okay, so let's say maybe our point will be there like that. Okay, then we said it casts the x and the it has the x and the x coordinates that we found on the x intercepts. We got something like negative 2.5. So let me put negative 2.53 here. Allow me to put it there. Let me say this is our point. Then on the other side we've got 0.53. Let me put our 0.53. Let me put it here. 0.53. Okay, so now when we join the graph, so it will pass from there, it's coming, and it will pass through this turning point, and it will go like that and like that. Okay, so it should be a smooth curve. Now you're realizing that it's cutting also the y the y axis there. So this point, what did we find as the y intercept? We said the y-intercept on that case was here 0, negative 4. So this is just a, let's say this is a negative 4. So you're done. So this is just a graph. This is a graph of f of x is equals to 3x squared plus 6x minus 4. Okay, so this is how we solve this one. Let's solve the last question. let's say you're given 5x. You're given f of x is equals to 5x squared. Okay, 5x squared, let me say, okay, let me 5x, okay, let me say 2x squared plus 8x minus 3. So what are we going to do in this expression? We're going to factor out 2 from x squared and in the x terms. So what are we going to do? So we have our f of x will just be equals to, when we factor out 2, you have x squared here plus, okay, that will just be 8 over 2. 8 over 2, that is just 4x, like we did that the previous one. Okay, this minus 3. Then we do what we did like earlier. So our f of x in this case will just be equals to 2. This is our bracket. Okay, then you're going to have 4, which is just 2. The half of 4, that's just 2, and you're going to square this 2. You're going to minus and plus. So let's just do it quick. So, and when you do that, you have x squared plus 4x. You have plus 2 squared minus, okay, let me just put this one in brackets, plus 2 squared minus, okay, minus 2 squared minus 3. Okay, then when you have that, okay, when we ignore this part, we just have our 2. You have 2. Then when you put those ones with the square, so just have x plus 2 squared minus 4 minus minus 3. Now that we have that, when we distribute the 2, what are we going to have? Okay, we can even solve on this one. Negative 4 minus 3. Negative 4 minus 3, that is just a 7. So that's negative 7. So what are we? Let's just put that there. Okay, so here we have a negative 7. Okay, a negative 7. Okay, a negative 7. Okay, when we do that, okay, when we do that, what are we now going to have? Okay, so now when we do this, we are going to have so in this case, when you distribute the 2, you just have 2 2x plus 2, this is squared, okay, minus, when you do your calculation, what are you going to have? You're just going to have your 7 there. Okay, then you realize that your turning point in this case, okay, there's somewhere here where I made a mistake. I'll say this one. It was supposed to be okay, this one was supposed to be okay. When we're distributing 2, we're supposed to get here, we're supposed to get 8, then 8 minus 3. This should have given us negative 11. Then the turning point in this case is just supposed to be, you get this one, which is which is positive 2. Now it's negative p, so in this case you just be negative 2. Then for your q, you just get the constant, which is negative 11. Then what are you going to do? You're going to find the x and the y intercept, and you're just going to realize that your graph will be something like, so your turning point is on the negatives, and the value of x, in this case the coefficient of x is a positive number, a is greater than 0. So in this case your graph will just be a minimum, right? So it will pass something like that through your negatives, but it will pass through your negatives and it will go like that. Okay, then you put your turning point, you find the y-intercept, and you find the x-intercepts like that. Okay, so that's how you're going to solve this one. Thank you. I'll see you in the next session.